Oh, okay. Hi. First off, this is not a tutorial. Because I feel like for a tutorial, like, the knowledge that you're teaching, you need to be, like, higher. And this is just, like, at my level. This is, like, the best I could do. So I don't feel confident teaching this. But what this video could be is laying out the whole process of designing a circuit board and sending it off to be manufactured and then building it at home. Yeah, it could be one of those videos. I basically just recorded this all at once, and I'm not trying to make this a step-by-step 45-minute long video because I don't think anyone has the attention span to watch that anyways. What I will do is break it up into what does building a circuit board look like, which is deciding what requirements your project needs, choosing the parts that fulfill those requirements, doing your homework and understanding how all of those parts that you chose work, and then building the theoretical circuit, which we call the schematic, and then building the physical circuit, which you can kind of see over here. You need to do some final adjustments to make sure that it's ready for manufacturing, and then you can test it on your own whenever it gets to you. So, I'm gonna keep it short, and let's get started. I've never really designed anything advanced in KiCad before. If you guys don't know what KiCad is, it's super open source free PCB design software, and people make some really cool stuff with it. Requirements shouldn't be the hard part. You're just asking yourself, hey, what do I want my board to do? And then, maybe, if I want my board to do these things, what do those things need to function properly? Like, what voltages do you need to work with? Those are all the types of things that will go into your requirements. ESP32. An encoder, I want it to have the motor controllers on board, generally like 2S to 3S LiPos. We want it to be small but manageable. So now we just gotta figure out how to do that. Alright, that was step one. You can get fancier, you can build a block diagram, but that's all it takes to define your requirements, and that's all you need to get started. Now go find parts that meet those requirements and understand how to use them. There's gonna be example schematics, and if there's not, then you gotta find similar components and examples of how other people have used those similar components. But there should be examples on how to use everything and what to consider whenever you're designing with this, because the manufacturers want people to know how to use their parts effectively, so they're not hiding it from you. You just gotta do a little bit of reading. And how to stack up your board. So if you're gonna have a 4-layer board, these are design guidelines, so if you need to mess this all up and you can do whatever you want. This is the TMC 6300, which is a pretty cool little chip. I like to have stuff in front of me in my notebook. You just gotta read a lot. That's the first step. Do your homework at the beginning so you don't have to redo work later. Alright, so now you're ready. You just go at it. Build the schematic, put together all of the example circuits that you've seen. You're gonna be designing the schematic and you're gonna be designing the board. You just gotta do what you gotta do. I don't have a lot of tips or advice to give here, so I'm gonna keep in this super clip of what it looked like for me to just kind of sit here and pull my hair out as I was learning. But it's not that bad. You can do it, just keep going. Oh, a big mistake that I made. I think it's a good idea to choose your manufacturer before you start designing the board layout and look for their design rule guidelines for successful boards that they're capable of making and how it affects the cost. And then you can set those rules in your thing before you design the board. Look, it's like the exact same thing. Bam, perfect. That was so exciting. I'm so fulfilled. Just go to good old Google. This is going so well. Charge pump voltage. All right, now we get it. Ooh, we got a color. Errors and warning 0. We can make this work. This always takes longer than you think. Should I be messing with this? Okay. So now let's close this footprint editor. Some encoder connectors that are gonna come in. These 4 outside ones need to be edited. Oh, how do I keep them from crossing? Still less than my maximum reading. We can just make 2 of these. That's pretty neat. The reference design told me to connect them and ground them. Is the yellow good? What's bad? Oh yeah, we're practically done. Now, let's check out the 3D viewer. Oh snap, no way. Oh my god, I'm so excited. You can pay money to have them build the boards for you, but I decided to do it myself with my own setup, and so here's kind of what that looked like. Boo! Here, all of the circuit board stuff, all in boxes, and we're gonna go to the garage, and I'm gonna show you guys what it looks like to assemble a board. what the values of everything is. You got your board set up, microscope so you can see the really tiny stuff, a really good pair of tweezers. I forgot to include the mask for this pin. That's just a mess up on my part. So we're gonna scrape it off. That way I can actually solder. All right, all fixed. Wasn't so bad. So then everything else is like decorating a cookie. You just take off these tiny components and put it on the solder paste and then heat it up and it melts together. I did buy the wrong USB-C connector, so we're gonna have to program some other way. I threw a blink sketch on this handy FTDI USB thing that I have, and then programmed it with the pins on the side of the board, and lucky for us, it worked first try. If you like this video, do stuff that helps videos. I don't know, I'm kind of new to YouTube, so I'd appreciate comments and suggestions and feedback and any of that. We're going to be posting a lot more about robotics and engineering and all of the goodies that we're learning and that we wish we would have known. But I am going to post a tutorial soon. It's just not going to be on a project this complicated. Thanks. See you guys.